Okay, this is the third and the final video segment for homework number 13. Let me see now. We have to do problem number 47. I can't remember. What was the last one that I did? I'm sorry, number 34. Number 34. Nope, number 45. Number 45. Number 45. Okay, we have to show or prove that 1 over 1 minus sine squared y is equal to 1 plus tangent squared y. Now, you can start with the left side, try to work your way to the right side, or you can start with the right, working your way to the left side, or you can simultaneously work and at some point show that the two are the same. Let me actually go that route, okay? So on this side, you have 1 over cosine squared y. And we don't know, but you want to see whether it's equal to this thing. So let me write that side as 1 plus sine squared y over cosine squared y. Okay. And I'll keep this thing, this side, left side the same. I'm not going to touch it again. But on the right side, there's a common denominator, cosine squared. So we get cosine squared y plus sine squared y. And notice that the numerator of this is 1. So is it equal to 1 over cosine squared y? The answer is yes. So left-hand side of the original expression is the same as right-hand side of the original expression, because at some point you manipulated both simultaneously, and at some point we came up with a statement that is obviously true. Let's go with the number 46. And it goes like this: prove or show cosecant of x minus sine of x equal to cosine of x cotangent of x. Once again, what I'm going to do is I'm going to go simultaneously. 1 over sine x minus sine x, is it equal to cosine x over sine x? Cosine x over sine x. Let's play with this. Common denominator is sine of x. 1 minus sine squared x. Is it equal to cosine squared x over sine x? And needless to say, you can see that the left side, the numerator on the left side, is actually cosine squared x over sine x. Equal to, yes, it is equal to cosine squared x over sine x. So we're done at this point. So we have shown that the left-hand side equal to right-hand side, because original left-hand side equal to original right-hand side, because we have traced them both down to a location where the two actually agree. 47. For some reason, I think I've done these, but anyway, it doesn't matter. I'm going to do it perhaps a different way. I guess some of you will get to learn something. Yeah, 47. These look familiar to me. See now, cotangent of x minus cosecant of x times cosine of x plus 1, is it equal to minus sine of x? I'm sure I've done this. I don't know. That's right. So let's actually play with this. Cotangent is cosine of x over sine of x minus 1 over sine of x. Yeah, I'm sure I did this. So I'm not going to finish it. Please go ahead and look at the other video segment. The previous one, second one, at the end, we have done this thing. I did this already. In video 2. Please watch it there. Okay, so 48. 48. You want to show or prove that sine to the 4 theta minus cosine to the 4 theta equal to sine squared theta minus cos squared theta. I want to remind you, remember that a to the a squared minus b squared is equal to a plus b times a minus b. This is from algebra. Okay, a minus b. Or a to the 4 minus b to the 4 equal to a squared plus b squared times a squared minus b squared. Minus b squared. Okay, so we have, what do we have here? Sine to the 4 minus cosine to the 4. Sine to the 4 minus cosine to the 4. Well, we just learned how you can do this. Sine squared plus cos squared times sine squared minus cos squared theta. But this is 1. So that is equal to sine squared theta minus cosine squared theta, which is exactly our right-hand side. We started with the left-hand side, and we ended up with our right-hand side. Okay, this is what we wanted to show right there. See this? Right there. Okay, let's do another one. Number 49. Number 49. 1 minus cos squared x times 1 plus cotangent squared x. You want to show it's equal to 1. Okay, so let's start right here. Well, first of all, this thing is sine squared. Left-hand side equal to, this thing is sine squared x. And over here, if you remember what this thing was, this was cosecant squared. But if you don't remember, just plug it in. Cosine squared x over sine squared x. So this is sine squared x sine squared x. Common denominator is sine squared x. Up there we have sine squared x plus cos squared x. But this is 1. So this is sine squared x, 1 over sine squared x, and this is obviously 1, which is your right-hand side. Okay, let me start with a new page so that this will not scroll up by itself. Okay, let's go to number 91. What it says is that, look, make this substitution, substitute this in that expression, and simplify. Okay, so we have x over square root of 1 minus x squared is equal to, well, x is sine theta, square root of 1 minus sine squared theta. But notice that underneath the radical is cosine squared theta, and this is sine theta over square root of cos squared is cosine of theta, and this is tangent of theta. So there we are. Number 92. Make this substitution. Take this, sub in square root of 1 plus x squared, and simplify. Well, square root of 1 plus x squared is equal to square root of 1 plus tangent squared. And if you remember what cotangent square was, which was secant squared theta, just use it. If you don't, just go ahead and plug in what you know. Sine squared theta over cos squared theta. This is equal to square root. Common denominator is cos squared theta. Up here we have cos squared theta plus sine squared theta. Square root of 1 over cos squared theta. And this is 1 over cos theta, which is secant of theta. And I said that if you remember that this thing was secant squared theta to begin with, then you can avoid all these things and come up with sine of theta. That's okay. Number 93, same type of problem. It says x equal to secant. Substitute in square root of x squared minus 1 and then simplify. So square root of x squared minus 1 is equal to square root of secant squared theta minus 1. Secant squared theta minus 1. But remember, secant squared is 1 over cosine squared theta minus 1. So under the radical, you have, you can take, combine these two, common denominator. You have 1 minus cosine squared theta, okay? But remember that numerator is just sine squared theta over cosine squared theta, which is sine theta over cos theta, which is tangent of theta. So if x is this, that expression is simply tangent of theta. Insert. Okay, let's do another one. Number 94. It says take this, x equal to 2 tan theta, sub in 1 over x squared square root of 4 plus x squared and simplify. Okay, fine. So we have 1 over x squared square root of 4 plus x squared. Let's stick it in. 1 over 2 tan theta squared square root of 4 plus 2 tan theta squared. So this is 1 over 4 tan squared theta. And underneath the radical, you have a common factor of 4. 1 plus tan squared theta. Now this 4 comes out, and you get 1 over 8 tan squared theta square root of 1 plus tan squared theta. I already told you that this is secant of theta right up there. So this is equal to 1 over 8 tan squared theta. That guy, secant squared, that's what I meant. Secant of theta. And, well, you can leave it like this, but in all likelihood, if you look at the answer in the book, they carry it one more step probably. So it's going to be 1 over 8 sine squared theta over cos squared theta times 1 over cos of theta. And this thing is going to be 1 over 8. This cos cube goes on top. And down below it, you just have sine squared theta. Well, the answer in the book may be like this or maybe like that. I don't know. You can check it out. Okay, so let's do the last block of problem. Number 97. Number 97, it says, okay, you have f of x equal to cosine squared x minus sine squared x, and g of x equal to 1 minus 2 sine squared x. It says, is f of x equal to g of x an equation or identity. Now, of course, one way is to, by brute force, go ahead and show that these are they the same or not. In fact, the problem says, prove your answer. Okay, so let me first, which I don't know. I don't know whether this is equation identity. If I plot this and I plot that, and they end up on top of each other, then obviously for every value of x, they are the same. Therefore, it's an identity. In fact, I'm going to do that. I'm going to plot both of these, show you they do in fact end up on top of each other. So it is an identity. Then I'm going to come and prove it. Okay. So let's go ahead to our calculator right here. I'm going to clear. I'm going to clear all of these. Okay. Let's go ahead and input our first function, which is cosine of x, close the parentheses, and square it, minus sine of x, oops, too many parentheses, x, close the parentheses, and square it. Then my second function is going to be 1, this is going to be your g now, 1 minus 2 times sine of x, close the parentheses, squared. If I graph both of these and I end up with a single graph in our workspace, means that actually they are always the same and therefore they're identities. Yeah, they will be the same. You can see that they will be the same. Now, actually, I don't like the way this graph looks like, so I'm going to change the range here because I think this range is not a very good one. Although it proves what I said, but it may be a good idea to change the range. Right now, minus 10 to 10. Okay, why don't I make this thing from minus, I don't know, minus 3 to 3? So, clear, negative 3 to 3. I'll leave y the same, and then I'm going to graph it. Okay. Actually, I didn't change the window. I didn't read that thing carefully. I don't know what it asked me. So let's try it again. Let's go to window. Minus 3 to 3. Okay, so enter. Oh, I think it's this scale. This scale, I have to change that. So I'll do 0.1. Okay, so this scale, I'll do 0.1. Maybe 0.1. Yep. Now graph it. Boy, this doesn't look. Let me change my window size again. So we go here. Okay. Default. What is the default value? Minus 10 to 10. Y max is let me also change the y min. Y min and y max to 4. So how do you do the, I don't want zoom box, the standard one, standard number 6. Let's go to number 6. Up, enter. There's something wrong with, okay, let's make sure this is right. Oh, what's my mode? Darn. So my mode, I want it to be in radian. That's what I want. Okay, that's what I want. My mode is in degree, and I don't want it in degrees. So let's go down here. Even the first one would have been okay. I didn't have to change the size, just that the mode I want it to be in radian. Go there, enter. Okay, good, good. And now we graph it. There, okay. Look, it's going to be a single curve. Just be careful with your mode. Degrees is not going to give you good stuff necessarily. So there's going to be a single graph. The other one is going to be on top of it. Okay, so let's go back here. I'm not going to worry about this. Let's go back here and now prove it, because we were supposed to prove this. It's very easy. So we want to know whether we start at the left-hand side, which is our f of x, which is cosine squared x minus sine squared x. And cosine squared x is 1 minus sine squared x. We know that. And there's a minus sine squared x here. And of course, this is 1 minus sine squared x minus sine squared x, which is 1 minus 2 sine squared x, which is our g of x, which is our right-hand side. Therefore, that is an identity. Okay, let's go to the other one. I'll do 99 first and then come back and do 98. Okay, this is number 99. Same question, when f of x is equal to sine of x plus cosine of x. Where is it? Yeah. Sine of x plus cosine of x squared, and g of x is equal to 1. The question is, are these the same? The answer is they are not the same. You might be fooled because you know that sine squared x plus cosine squared x is 1. But this is not the same as what f of x is. So how do we know? We can go and input these two and plot them. There should be two separate graphs. So let's go to our calculator, and I'm going to clear everything. Okay. So we go to our function right there. We're going to clear these and clear the next one, and we input our stuff. You go up here, is parentheses, sine of x, close the parentheses, plus cosine of x, too many parentheses here, cosine of x, close it, close the parentheses, and square it. And for the second function, we just the function 1, identical 1. So let's graph this. One of them is going to be horizontal straight line. The other one is going to be some kind of a sinusoidal curve. You can see that. This is the first function. The other one is just going to be straight line. Obviously, they're not the same all the time. Therefore, this is not an identity. This is an equation. Okay? It is an equation because only at specific points they're the same. Not identity. In fact, if I didn't have my graphics calculator, all I need to do is to set x equal to, for example, let's say x equal to, I don't know, maybe pi over 4. Okay, so f of pi over 4 is equal to root 2 over 2 plus root 2 over 2 quantity square, which is root 2 quantity square, which is 2. And you can see that this is definitely not equal to 1. All right. So the last problem that I want to do is here. F of x is number 98. Now f of x equal to tan of x. 1 plus sine x, 1 plus sine x, and g of x equal to something ugly, sine x cos x over 1 plus sine x. Now, just by looking at this, I can immediately see that these are always the same because just look at it. Tangent of x is sine x over cosine of x. Oh, wait a minute. I'm sorry. Just by looking at this, I can see that these are definitely not the same because a tangent of x is sine x over cosine of x. And if you put, these are in the wrong spot. But let's say we don't know. This is not an identity, I guarantee you. But let's go ahead and actually plot. Clear these things. Clear these. Go to our function definition. Clear these. Clear the next one. And let's go plug it in. My first function is tan x, tan of x, parentheses, times, parentheses, 1 plus sine of x. 1 plus sine of x, close it, and close it, and close it. Next one is sine of x times cosine of x divided by parentheses 1 plus sine of x. Right there, too many parentheses here. So backspace, x, close the parentheses, and close the parentheses. Now if I graph, there's going to be two separate graphs. The only thing that bothers me, that denominator may be 0, so there will be asymptotes for sure. Right there, you can see that. There we are. This is the first one. It's got asymptotes, of course. And then there's going to be a second one, which also has asymptotes, but these graphs are not going to lie on top of each other. Therefore, this expression, f of x equal to g of x is not an identity. Okay, we don't have to finish this thing. Right here, so we go there, not an identity. And in fact, we can take, for example, x equal to, I don't know, maybe pi over 4, try it, stick it in there, the two are not going to be the same. And that completes the solution for homework number 13.